example 4, we're going to look at what happens when we take the area between curves and then revolve them around an x-axis or a line. So in this example, let's look at this function. And here we have cosine of x and here we have sine of x to where they intersect at pi over 4. And what we're going to do is we're going to take this area and we're going to revolve that around this axis. So it's going to get spun around. Now in previous examples, we've only looked at when you revolve a single function. So in 3D, what this looks like is this. So when I spin this around, it starts to create two shapes where one shape is inside the other. So the orange function is cosine of x, and the red function is sine of x. And so as you can see, you have an outer shell and then an inner shell. And what we want to do is find the volume that this region creates between these curves. So I want the volume that's inside of the orange, but I want to get rid of the volume of the red piece in here. So we're going to do that in a very similar way that we did with area between curves. When we would subtract one function from another, we're going to find one volume and then subtract off the volume we don't want. So example 4, the washer cross-section. The region in the quadrant enclosed by the y-axis and the graphs of y equals cosine of x and y equals sine of x is revolved about the x-axis to form a solid. Determine the volume. So the first thing we need to do is graph both of these in our two-dimensional plane. So when you do that, we get that this is cosine of x and this is sine of x. And so if we were to revolve these by themselves, we would get that from here to here, we have one radius r. And so cosine of x, from here all the way down to the bottom, we're going to get capital R. So we have two distinct radii. If I were to revolve this around the x-axis like that, I would get something that looked like this in the two-dimensional plane. And so what we're going to do here is we're going to actually create the disk for each one. So if you look at the inside one, we're going to get certain disks. And so if we look at these shapes, we can see that they make disks. And so now we're going to take a closer look at those disks and determine how to find the area of each one. And so if we look at this, we see that from the center to the outer ring is the large radius, and from the center to the inner ring is the inner radius. So if I want to find the area of just the colored in region, I would do the area of the large one minus the area of the small one. Well, since the area is pi r squared of a circle, the total area would be pi times capital R squared minus pi little r squared. And that would give me the area of each washer. The area of a washer is A of x is equal to pi capital R squared minus pi times little r squared. And an easier way to write that, a little more simplified, is pi parenthesis capital R squared minus little r squared. area is not pi times big R minus little r squared. This is a common mistake that a lot of calculus students mess up on. You have to square the outer radius and then square the inner radius and then subtract. Don't subtract and then square. So now let's go into determining the volume of this shape that we had originally. So our volume is equal to the integral from 0 to pi over 4, because these are the intersection points, of pi times the outer radius squared, and so that was cosine, so cosine squared of x, minus the inner radius squared, which is sine squared of x, dx. And here we're going to need a trig identity. And so that trig identity is going to be cosine squared of x minus sine squared of x is equal to cosine of 2x. So this is a double angle formula that you have to know. And so from that, we're able to get that volume is equal to pi integral pi over 4 of cosine of 2x dx. So then we integrate and you get volume is pi times sine of 2x divided by 2 from 0 to pi over 4. If you need to do the u sub, take a step out to do that. So volume is pi over 2 times sine of pi over 2 minus sine of 0. And I got the pi over 2 by substituting in the pi over 4. So volume is pi over 2. Sine of pi over 2 is 1 minus 0. So the volume is pi over 2 units cubed. So now what I want you to do is try to determine the volume by revolving the region bounded by the equations below about the x-axis. Alright, so here we go. So first step is to graph it. And we're going to do this by hand. Okay, so after we have that graphed, we're going to label both functions. So this is y equals x squared plus 1, and this is y equals x plus 3. Now graphing will give you approximately the intersection points, but we want to determine what they are actually. And so we get that y is equal to x squared plus 1, and y is equal to x plus 3. So we set those equal to each other. We get x plus 1 equals x plus 3. And then when we solve that, we get x squared minus x equals minus negative 2 equals 0. So you factor that, get x minus 2, x plus 1 equals 0. So you get x equals 2 and x equals negative 1. So we make sure our x values are right. So this should be x equals negative 1. And this should be x equals 2. So the next step now is to revolve this around the x-axis. So we're going to take this closed region right here, and we're going to spin it around the x-axis. So we're going to take this thing and rotate it. So this is approximately going to look something like this and like this. And so we're going to create washers that look like this. Now I'm going to graph this a little nicer so you can get an actual picture of it. So when we graph it, we get something that looks like this. And so what we're going to do now is we're going to use this to create our washers, where this is y equals x plus 3, and this is y equals x squared plus 1. So the inner ring is going to look something like this, and the outer ring is going to look something like that. And our goal then is to find all this area in between. So our integral is going to be from negative 1 to 2, and this comes from our intersection points, times pi, and then our inner radius is going to be x squared plus 1, and our outer radius is x plus 3. So we get x plus 3 squared minus x squared plus 1 squared dx. And if this was on a calculator portion of the test, you could just plug in a calculator, but we're going to go ahead and solve it by hand. And so you're going to get 117 pi divided by 5 units cubed, which is approximately 73.513 units cubed.